Now we are going to talk about ray diagrams for concave mirror. Okay, so this is the concave mirror, right? The midpoint of the spherical mirror is called pole. The center of the sphere is called the center of the curvature. A line joining the pole and the center of the curvature is called a principal axis. When parallel beam incident on it, after reflection all the light rays meet at one point, that is called focus. Okay, so now we can place the object at different points. So now I am going to talk about the first case. Object is at infinity. Object is at infinity. Okay, so before going to draw the ray diagrams, quickly we will recall the rules. Okay, pole, focus, center of the curvature. Pole, focus, center of the curvature. These are the rules we use to draw the ray diagrams. Now, object is placed at infinity. This is case number 1. Object is at infinity. So, what kind of rays are coming to meet this mirror? Parallel beam. So, I am going to consider a ray passing parallel to the principal axis, above the principal axis and below the principal axis. I considered 2 rays. Okay, now, and one is along the principal axis also. A ray is coming along the principal axis. So total 3 rays I have taken. After reflection, what happened? All the light rays, rule number 1, a ray passes parallel to the principal axis, after reflection passes through focus. How is this ray? This ray is parallel to the principal axis. So according to rule number 1, any ray passes parallel to the principal axis, after reflection passes through focus. So here also, after reflection, the ray passes through focus. This is. And here also you see, any ray passes parallel to the principal axis, after reflection passes through focus, according to rule number 1. And this is the ray passing through the center of the curvature along the principal axis, after reflection traces the same path. Rule number 3. Any ray passing through the center of the curvature, after reflection traces the same path. Here also the ray passing along the center of the curvature, so after reflection traces the same path. Then all the light rays meet at one point. Here the image is formed. This is image. Whose image? This is the image of object which is placed at infinity. Object is at infinity, that object image is formed at the focus. Okay, so when object is placed at infinity, what is the position of the image? Where does the image form? Position of the image and also nature or characteristics. See, I'll explain. Position of the image. Where is the position of the image? At focus. Image formed at focus. What is the nature of that image? This is point size image. And where is the image formed? Before the mirror or behind the mirror? Image is formed before the mirror, because after reflection light rays are converging. If the image is formed due to the converging rays of after reflection, that is called real image. So real image generally forms before the mirror. Image forms before the mirror. So it is called a real image. Why it is called real image? Because image forms before the mirror. When does image forms before the mirror? Actually, if the rays converge after reflection, image forms before the mirror. Imagine if the same rays diverge this way, what happen? Image forms behind the mirror. But does it form? No, image forms before the mirror. That is real image. Okay? Now we are going to talk about the remaining ray diagrams. Object is beyond C. Beyond C. Okay? When object is placed beyond C, this is object. Now, according to rule number 1, a ray passes parallel to the principal axis. After reflection, it passes through focus. And rule number 2, any ray passes through focus. After reflection, passes parallel to the principal axis. So, a ray passes through focus. After reflection, passes parallel to the principal axis. Okay? So this is incident ray, this is reflected ray. This is incident ray, this is reflected ray. See, this is the reflected ray and this is the reflected ray. See, both the reflected rays are meeting at this point. So this is the tip of the object. The base of the object is on the principal axis. The image base is also on the principal axis. So the image forms this way. Image is formed below the principal axis. Okay, so this is image. What is the position of the image? Position of the image. Object is placed beyond the center of the curvature. Their image is formed between focus and the center of the curvature. Between focus and the center of the curvature. Okay. Now, nature, characteristics of the image we are going to understand. See, you see the size of the object and you compare the size of the image. Okay. Is the size of the image and size of the object same? No. Size of the image looks smaller than the size of the object. If the size of the image is smaller than the size of the object, we call it diminished image. So the image is diminished. And where is this image formed? Is this image formed before the mirror or behind the mirror? Before the mirror, because rays are converging after reflection. That is why this image is called real image. Real images generally forms before the mirror. If the rays diverges, we have to extend them backside. Behind the mirror image form, that is virtual image. But here that thing was not happened. So after reflection, all the light rays are converging before the mirror only. So real image. And one more important thing, this is principal axis. Object is upright. Object is like this, but image is like this, inverted. Image is formed below the principal axis, so it is inverted image. Okay, so these are the characteristics of the image. Once again, tell me why it is diminished image? Because size of the image is smaller than size of the object. Why it is real image? Because image is formed before the mirror. Okay, why image is formed before the mirror? After reflection, light rays are converging. That is why it is called a real image. Inverted, because image is formed, this is principal axis. Object is upward the principal axis, but image is downward the principal axis. Image is formed downward the principal axis. So it is called inverted image. Okay, these are the characteristics of the image formed by the object which is placed beyond center of the curvature. Okay, so now we are going to talk about another important, that is object is at C. Object is at C. Now I am going to keep the object at the center of the curvature. You see, whenever you want to draw the ray diagrams, you have to take the distance between pole and focus and center of the curvature must be same. Okay, then only you will get the ray diagrams for sure 100%. If you don't maintain these distances are equal, you never get the ray diagrams properly. That is why whenever you draw the ray diagrams in your notebook, after drawing the arc with compass, you have to take 6 centimeters from pole to focus. The distance between pole and focus you have to maintain 3 centimeters. Focus and center will be also 3, so the distance between pole and center will be 6. While drawing the ray diagrams, until this lesson finished, you maintain the same length, okay, same dimensions. Always you have to draw the arc with 6 centimeters now. Okay, so the distance between pole and center will be 6 centimeters, then pole distance between pole and focus will be 3 centimeters. For any diagram you maintain the same measurements. Okay, please take the same measurements so that you will get the ray diagrams properly. Here object is placed at the center of the curvature. Now I am going to keep the object at C. This is the object placed at C. Okay, what is our rule number 1 to draw the ray diagram? A ray passes parallel to the principal axis, after reflection passes through focus. So here a ray passes parallel to the principal axis, after reflection passes through focus. Okay, second rule, any ray which is coming from the tip of the object and passes through focus, after reflection passes parallel to the principal axis. So I consider this, you say this ray passes through focus, then after reflection passes parallel to the principal axis. So this is passing parallel to the principal axis. So little bending down, passing parallel to the principal axis. Okay, and this is coming this way. See, both are meeting here. Where are they meeting? They are meeting here. So this is the reflector ray and this is also reflector ray, right? So both the reflector rays are meeting at this point. Okay, so this is the image. Okay, now what is the position of the image? Okay, and the nature of the image. Position, object is at C, image also form at C. Okay, when object is at C, image also at C. In this case, object distance is equal to image distance. For plane mirror, always object distance is equal to image distance. In concave mirror, only in one case, object distance is equal to image distance, that is when object is placed at C. Okay, but remaining all the cases, object distance and image distance are different, but here same. What is the nature of the image? As we have discussed, is this image is diminished? No, size is same. Okay, that is why same size. Is this image formed before the mirror or behind the mirror? Before the mirror, due to converging of the reflected light rays. So that is real image. And this image is formed below the principal axis. So usually that is inverted. Okay, inverted. So most of the times this inverted image you see in your daily life when you see your images in spoon. Because spoon surface is bent inwards, this kind of phenomena takes place. Then inverted image is formed due to that curved inward surface. Inward curved surface. Understand why our image is completely different when we observe through the spherical mirrors or spherical surfaces? This is the phenomena takes place. That is why images appears inverted. Okay. And third, another important position we are going to talk about, that is previously infinity finished, beyond C finished, at C finished. Now we are going to keep the object between focus and the center of the curvature. This is focus and center of the curvature. If the object is placed between focus and center of the curvature, okay, object is between F and C. Now a ray passes parallel to the principal axis, after reflection passes through focus. Rule number 1. Rule number 2, a ray passes through focus, after reflection passes parallel to the principal axis. Right? You see, I am going to tell you, this is the reflector ray, and this is also reflector ray. Both reflector rays are meeting here, so the image is formed here. This is the image, right? So what are the characteristics of that image? First we will understand position of the image, and we will understand the characteristics of the image. Where is the object placed? Object is placed between focus and the center of the curvature. Focus and the center of the curvature, right? When object is placed between focus and center of the curvature, image is formed beyond C. You see, when object is beyond C, image formed between focus and center of the curvature. When object is placed between focus and center of the curvature, image is formed beyond center of the curvature. Okay, so these are completely opposite phenomenons, right? Now you see position of the image. Where is the image formed? Beyond C. When does image form beyond C? When object is placed between focus and center of the curvature, image form beyond C. This is also called focal point. When object is placed between focal point and center of the curvature, image form beyond C. What is the nature now? You see the size of the object and size of the image. Image size is bigger than object size. When the size of the image is bigger than size of the object, we call it enlarged image. Enlarged, magnified also. And is this image formed before the mirror or behind the mirror? You see where it is formed. It is formed due to the converging of the reflector light rays. So is it a real image or virtual image? Real image. If the image formed before the mirror, real. Behind the mirror, virtual. Okay. Why image formed before the mirror? Due to the converging of the reflector light rays. Why image formed behind the mirror? Due to the diversion of the reflector light rays. But here rays are converging. That is why it is real. Next. This is principal axis. Is this image formed upward principal axis or downward principal axis? Downward the principal axis. So this is called a inverted image. Okay. So these are the ray diagrams. Still two more cases we have. We have placed the object beyond center of the curvature, at center of the curvature, between focus and center of the curvature. Two more ray diagrams we have. That is, one we have to place the object at focus and between pole and focus. So meanwhile, please note down these ray diagrams, draw the ray diagrams neatly and write the characters in your notebook. Previously we have discussed the ray diagrams up to object placed between pole and focus. Now we are going to talk about another ray diagram by concave mirror. Object is placed at focus. At focus. Now object is at focus here. Right? Now rule number 1. A ray passes parallel to the principal axis. After reflection passes through focus. This is rule number 1. Any ray passes parallel to the principal axis, after reflection passes through focus. Rule number 2. A ray passes through focus, but you see if the ray passes through focus, it doesn't meet the spherical mirror. Then we don't use rule number 2. In this case, we use rule number 3. Any ray passing through the center of the curvature after reflection traces the same path that we are going to see here. So any ray passing through the center of the curvature, how it is possible? You see, already we have discussed, when object is placed this way in front of the mirror, many light rays are coming to incident on the mirror this way. I told you already, right? Here also a ray going to meet this way after reflection passes through center of the curvature. Okay, so this is a ray. After hitting the mirror, it passes through center of the curvature this way. Okay? See, these two rays are parallel to each other. Do they converge? Is there any chance of meeting? Do they converge? No. They don't converge. Whenever the rays converge, their only image is formed. Then only image is formed. But here the rays are not converging. Then technically there is we are understand image does not form. But since mirrors form the images, we understand that this mirror, in this particular case, when object is placed at focus, image forms beyond, very beyond, that means very far away, that is called infinity. Okay, already first case we have discussed, when object is at infinity, parallel beam incident image is forms at focus. Here when object is at focus, image forms at infinity. When object is at infinity, image forms at focus. When object is at focus, image forms at infinity. Okay, so in this case, object, what is the position of the object? What is the position of the object? Infinity. At infinity. Image forms at infinity. You go on extending, go on extending. And what is the nature of the image? Nature. The nature of the image is highly enlarged. If the image is formed here, if you draw the principal axis, you see highly enlarged image is formed. Okay, but in our textbooks, academic textbooks, we don't have any characteristics, especially regarding this case. Okay, in some textbooks it says image forms at long distance, that is why image is highly enlarged. Okay, and the last character and the last ray diagram we are going to talk about. Okay, now object is placed between pole and focus, P and M. When object is placed between pole and focus, you see a ray passes parallel to the principal axis, after reflection passes through focus. Here also we don't use the second rule, we use the third rule. A ray passes through center of the curvature, after reflection traces the same path. Okay, ray after hitting the mirror, after reflection passes through center of the curvature, and this ray passing through focus. Okay, see what is happening, this ray is passing through focus after reflection, this ray is passing through center of the curvature after reflection. How do they seem? They seem diverging. Is there any chance of meeting? So there is no chance of formation of image before the mirror, but we have to extend them backside. When we extend them backside, they will meet here. Okay, here the image is formed. This time image is formed behind the mirror and image is formed upward principal axis. Okay, now, so what is the position of the image? What is the position in this case? Position and nature we are going to. Position, nature. See, this is object. Where is the image formed? Behind the mirror. Behind the mirror. Behind mirror. And what are the characteristics of the image? Compare the size of the object, size of the image. Size of the image is bigger than size of the object. So it is enlarged. One more important thing. This time, after reflection, light rays are diverging, not converging. If the rays converge after reflection, real image is formed. You see here, real image. But here rays are diverging. So we have to extend them backside. So image formed behind the mirror. If the image formed before the mirror real, behind the mirror virtual. So the image is virtual. Okay? And this time image is formed upward principal axis. So image is erect or upright. Okay, object is this way, image also this way. Image is not this way, image is this way. This is erect image. Okay, so these are the ray diagrams for the concave mirror. So please practice the ray diagrams. This is one of the important questions in board examinations. Not only right now, again these will be repeated in the intermediate second year. So learn the basics, learn the rules to draw the ray diagrams, practice the ray diagrams. Okay, I hope students you are understanding all the concepts clearly. We will discuss more and more ray diagrams of convex mirror and some problems, some numericals, mirrors formula, mirrors equation. So each and every topic, each and every subtopic very clearly we will discuss in coming videos. I hope you are enjoying the videos. Please note down all these things, maintain the notes properly, please. Okay children, we will meet in the next video.